Everyone, my name is Brandon Kramer. I'm here at Rutgers and conducting a training for the EMP lab. Basically, in this lab, we're going to go over heart rate variability and go over the basic concepts of cardiovascular psychophysiology, as well as some detailed information that you'll need if you're working in the lab, just for the sake of assignments as well as saving protocols. So we'll jump right in. Throughout this module, as well as the 6 other modules that accompany this, you'll see that there are a number of different training portions or different points that we point out in each video. Again, I'm going to just cover the initial basic concepts and terminology, and you can reference all other modules for this information at a later date. So the basics here in cardiovascular psychophysiology are that cardiovascular psychophysiology is a field that's mainly concerned with understanding the physiological basis of psychological processes. Now, I'm wary of saying that that's a strong statement, just for the fact that it's often quite difficult to learn about psychological processes from how the heart works or how the autonomic system generally works. However, we know that experience of reality doesn't just align with what's going on in the brain or one's subjective experience, but there are also a lot of unconscious processes that cannot necessarily be understood through deliberate thought. So we're trying to tackle these issues and trying to look at the dynamics of the autonomic nervous system more specifically, and we can do this by looking at cardiovascular mechanisms and other autonomic mechanisms. So the 5 most common measures, perhaps within cardiovascular psychophysiology, are these 4 measurements here, or core methods at least. And we're only going to focus on the top 3 throughout the course of this training, because heart rate variability, and blood pressure are the measures that we're really interested in analyzing within the course of the EMP lab. So this is just a brief overview. I'd highly suggest looking at this link from Thomas Komarek, who's a great researcher. He gives a very somewhat extensive overview to introductory cardiovascular psychophysiology in this lecture here. So you can just visit it on YouTube at a later date. We're just keep moving forward for the time being. So just to kind of give a general overview of what heart rate variability is, we need to understand first what ECG is. So electrocardiogram allows us to measure how the heart oscillates from moment to moment within the course of our experiments, and we can also collect data over, ambulatory data over the course of 24 hours or even longer. Many people are now using ECG data to quantify their heart rate and heart rate variability over the course of weeks. They'll wake up every morning and measure their heart rate variability, and this will give them a good measure of how their training's working out, how they slept. It really gives a strong, robust measure of how your health is doing, if you can interpret that. So we're basically just we collected ECG data within the EMP lab. So we're looking to understand how the heart functions both within the course of the study, as well as what that data can tell us about participants' dispositions, or if they have background, heart problems, or even general health problems. And some of this can be understood through doing this analysis. So the main point of getting that ECG data and looking into heart rate variability is that we really need to reduce all of this data to an interpretable way, or an interpretable information or statistics. And how that's done is basically by looking here at the QRS complex. You'll see that in the yellow section here, we have a point and it jumps up. This is called the R spike. This R spike is extremely important for HRV because basically there's quantifying all of the R spikes, or all of the valid R spikes, throughout the course of the entire experiment, and then trying to deduce measurements from that. The main measurement that we're going to be looking at is interbeat interval, which is basically the dynamic changes between R spikes throughout the course of a study. So interbeat interval is important because it can tell us things not only in the course of the experiment, like posture, stress, and then general arousal, but also some health predispositions. The higher one's heart rate variability means that they have more variability in their heart, which is actually a sign of good health. lower heart rate variability you have, the more it suggests that you're actually you're struggling with some health issues, or your general physiology isn't adaptable. So we collect this by looking at the IBI. We're basically looking to quantify all these R spikes here throughout the course of the study, and we do this by using algorithms to mark first all the R spikes, and then our job is to manually go over those algorithms that are being marked, and then we can kind of tell which points are valid and which ones aren't. So IBI tells us very little alone. It is an important measure, and it is reported in most journals. But IBI also helps us to understand just general heart rate, which is a variant of IBI. It's just a different measurement. IBI is in milliseconds, heart rate is in beats per minute. But we can also learn more about heart rate variability or respiratory sinus arrhythmia. And this is basically the heart's oscillations in correspondence or in concert with the respiration rate. So this is all rather technical, and you can look up this information on your own if you're looking to find out more specifically what that is. I'll touch on it briefly after this, but what you need to know basically is that RSA is often considered the same as HRV. We're talked about in the same way. However, they are distinct things. So heart rate is different, so IBI is different from heart rate, which is different from RSA, which is different from heart rate variability, or is a more specific way of saying heart rate variability. And by understanding this RSA measurement, we can learn more about how the vagal nerve is working within the body, and generally how that corresponds to parasympathetic nervous system activity, which is kind of the relaxation, or how the body the system that kind of allows us to relax and kind of turns off our sympathetic or our fight or flight responses. So we can also find additional heart rate variability information from the IBI, but these measures are typically used more commonly within 24-hour periods. RMSSD will be of interest to us, but that will be done automatically within the program, obviously. So how do we quantify these measures? Basically, what we need to do is we need to look through ECG data and try to simplify that data by looking just the R spikes, and by gathering information on the R spikes, we can see how much variability there is in each minute of the data. So we're interested in just basically looking at all the R spikes and then looking at the means of those differences over each minute of the data that we have. Here I've included some data from one of my experience, and you can see that the heart rate, in the first minute started low and actually got a little bit higher throughout the course of the 5-minute baseline period, which isn't ideal, but in this circumstance, it varied rather little. So generally, programs help us quantify all these measurements, but just one small error in the IBI or in the marking procedure can cause a radically different measurement. I'm going to actually pull up the HRV program right now and kind of look and see when this is the case. So I won't go into the details of what buttons I'm pressing, but it's important just to look here at the bottom here and see that the RSA measurement is 5.49. Now this is a fairly common measurement, and this seems to be correct. We really don't have any problems. You can see all the blue markings up here are valid R spikes. However, if we go in here and we just randomly delete a point right here and then press OK, we can see that the RSA jumps about 3 points. So the main point is that we need to properly mark all the R spikes, and when we don't properly mark them, it can drastically influence our measurements. Just 1 point can drastically move an RSA, for instance, by 3 whole points, which is a really, really drastic difference. So generally what HRV is in a more complicated or sophisticated way, is looking at the IBI or heart rate and then running them through spectral analyses, and we can see at different frequencies that we have different waves of information that we can interpret here. And basically what you need, although you don't need to know this, a basic way of understanding this is we're looking at the area below these curves here and trying to understand how much of that area corresponds to these different frequencies. Now, this very low frequency and low frequency correspond to a mix of parasympathetic and sympathetic activity. However, in this high frequency range, we know that mostly parasympathetic activity is taking place. So again, you don't need to know all the specifics of this, but I thought I would point this out that you'll hear about very low frequency, and high frequency when you set up your program. And generally what these different frequencies align with are, again, a mix of sympathetic and parasympathetic in the first two power domains. And then this last one is mainly parasympathetic activity. And this is where we gather our RSA measurement and HRV high frequency measurement from. So I gave a little glimpse already into the ECG data, what mindware looks like. In an ideal circumstance, you're going to have the program perfectly mark everything. You're going to have all your R spikes already taken care of. In other sequences, you're going to have a bunch of mess, basically, where artifacts show up within the context of the data. We'll go over in detail within future video modules how to deal with these issues when they're not perfect. But I just wanted to give a look at see what mindware actually looks like. So a general overview of the comfort eating study is that we basically have five portions of the data that we're really interested in looking at. And so when the participants initially come in, they fill out their informed consents and surveys, and then they take part in a baseline task. And this baseline task is what we're initially going to quantify. It's going to be known as O1 in the course of your study, or of the course of your analyses. It's basically a 5-minute period where participants complete a baseline procedure. They sit at a computer counting squares, as well as doing a paced breathing exercise. And this baseline allows us to compare resting state physiology to more stressful circumstances. From there, we'll definitely quantify the baseline 5-minute period, and then from there there'd be 11-minute true social stress test period where participants are doing an arithmetic task and then doing prep for a speech. So this is in total, this stress test is about 11 minutes. We'll quantify all 11 minutes of that within heart rate and blood pressure. And then from there, we'll quantify a 3-minute recovery period where participants are doing surveys. From there, participants are then given 5 minutes of emotion regulation manipulation where they're given food and have to deal with this particular task. So this goes about 5 minutes. We'll quantify all 5 minutes of that and then quantify 5 minutes afterwards where participants are filling out surveys. So in these 5 different segments, the baseline, TRIR, recovery, emotion regulation, manipulation, and the recovery from that, this will give us a good idea of how participants react to stress, how they calm down, how they react to stress again, and how they recover from that. And this will generally give us an idea of how our particular sample here is reacting to all kinds of stress. So general materials that you're going to need throughout the course of your analysis. First is editing materials. And I can just pull up editing notes here. You'll see that we have a big file here of all these editing notes. And basically what you'll need to know is that there's first column here where marks out O1, O2, O3, O4, and O5. This lines up to the baseline, this true social stress test, the first recovery, the food manipulation, and the recovery from that. This section is just run over in case you would run into circumstances where the file goes on a little bit longer than you'd expect. I don't expect this to be used, but it's always helpful to add this in just in case. Generally what you'll need to know is that up here in the file number, this will always align to your experiment number. The coder name will then be in here. You can go ahead and type in your name. And then once you complete that, you'll be using the color purple to diagnose that to designate that you've finished the file. Generally, other things that you'll need to look at are using these features down here in the legend to copy and paste information in here. I won't go into detail here how the editing notes work because you'll see that in the 3rd module. So generally, you just need to know this information here, that this is the editing notes. We also have a paper protocol that you can reference in addition to these tutorials. You'll have an analysis guide that I've outlined here that has all the information as far as start times, end times, and the 2 different coders that are doing every file. That's all the information I think you should need. It'll be important to save all your information in the proper folders, so just keep that in mind, and we'll go over that in the training session. So and throughout the course of these analyses, we'll be starting off with HRV. Ali and Rana will be doing 101 to 140, Lene and Megan 141 to 180, and Margot and Shadia will do 181 to 219. It'll be pretty straightforward. All the files are already set up for you, so it'll mainly just be clicking through those folders, opening up the program, and pulling the files from the folders that you're supposed to. It will be important, however, to save all your information in the proper place. And all this is outlined in the protocol, exactly where to find your information and where to save your information. The things that are very vital are that you save everything in the correct path locations. So you can find all your protocols here, you can find the individual files here, and it's important that within these individual files that you locate your personal file and save all your information in the correct files. For instance, if you're working on file 101, it'll be important for you to save the information according to the saving procedures here, but that you save that information as far as editing notes, output files, etc. in that folder. It's not necessary to move it anywhere else besides that folder. This will help us keep everything formatted and organized in the proper way. There's another issue with Mindware files, that they need a particular format. There'll be some circumstances where your files will, for instance, if you're opening up Mindware right here, there'll be circumstances where you click on a file here and it will not open properly. And if that circumstances happen, if these numbers don't populate over here, for instance, you know that your file has not been converted correctly. So in those circumstances, you'll just have to reconvert the file, and you can access that information via the protocol. To the best of my knowledge, all of this formatting has already been done, so you really won't have to worry about those issues. Lastly, we have the saving information. We have a master editing notes, and so we have a master editing notes and master analysis file. I suggest making a copy of those master files and then pulling them into your original file, and then saving your initials and a date at the end of every time that you do an analysis, or at the end of every day at least. That said, I would suggest that every single day that you do that particular analysis, that you save with a different date, and this will help you, get around issues where you're constantly saving over data and potentially eradicating any vital information that you need. So it's best just to keep all those files as far as editing notes, as well as other information here. When you're saving your editing files, and I know we're not familiar with the program yet, you can access your editing files within Mindware by clicking here. You see that I don't have any editing files yet. However, one thing that is important is that when you go in, you'll need to go ahead and save any kind of editing that's made. I'll go ahead and just make a slight edit here, and then click out. And you'll see that this information will come up if you do make any editing changes within Mindware. You can simply save this information by clicking O1 and saving that. Although it says A1, I would highly suggest you click O1 to correspond to the editing notes. Lastly, output files that you'll be outputting via the program. When you go in and actually output your files, this will be done by clicking Write, and this will correspond to an Excel sheet. When you click Done, that information will automatically save and automatically go into your individual folder. It's important that after you're completed with the entire file, you take all those files and rename them according to this procedure here. So you have CE ID 140, and then you'll change this to, rather than A1 or A1 or A4, you'll have 01, 02, 03, 04, or 5. And then you just put your initials and the date. You want to put all this information in your individual folder, rather than tucked away far and back. We can go over this in the training, and if you have any questions, you can also ask your supervisor about that. For the time being, I'm just going to go ahead and move ahead and say that that's it for this particular training module. If you do have any questions, be sure to ask your lab supervisor. It's best to always ask questions and have the vital information that you need.